Hello everyone, my name is Arindam Sharma. I'm a faculty of Department of Computer Science at Kristu Jayanti College Autonomous, and today we will talk about the Unit 2, that is Process Management of Operating System and Linux. So process concept. First of all, we have to understand the concept of a process. Process management for a single tasking or batch operating system is easy as only one process is active at a time. So when it is a single tasking system, single tasking means where there will be only one process. It will be very much easy for them. With multiple processes, within bracket, you can see it is written multi-programming or multitasking. So multi-programming means when there are more than one programs, there are multiple programs or multiple tasks are getting executed. Okay, so this means that being active, the process management becomes complex. So whenever there are multiple programs are running, then only the management of these processes becomes complex, because CPU needs to be efficiently utilized by multiple processes. Since there are a lot of processes are there, so the CPU needs to be used efficiently. Next, multiple active processes may share resources like memory and may communicate with each other. This further makes things complex as an operating system has to do process synchronization. So these things are really important because it can share resources like memory. Okay, memory is shared among the processes, and when it is supposed to share the RAMs, more specifically, more precisely, the RAM to lot of processes, so it has to be handled in a very good manner. Otherwise, it might not work properly. So let's understand CPU bound versus input-output bound processes. A CPU-bound process requires more CPU time and spends more time in the running state. An input-output IO-bound process requires more IO time and less CPU time. So this is it. An input-output bound process spends more time in the waiting state. Process planning is an integral part of the process management operating system. It refers to the mechanism used by the operating system to determine which process to run next. The goal of process scheduling is to improve the overall system performance by maximizing CPU utilization, minimizing throughput time, and improving the system response time. So these three things are really, really important. CPU utilization, it needs to be maximized, and minimizing the throughput time, and also improving the system's response time. So these three things are the really important things. Now the process management tasks. So what are the tasks it is all about? Process management is a key part in the operating system with multi-programming or multitasking. Process creation or termination, CPU scheduling, deadlock handling, inter-process communication, and process synchronization. So let's understand what it means by creation of a process and termination. So process creation involves creating a process ID, setting up a process control block, etc. A process can be terminated either by the operating system or by the parent process. Process termination involves clearing all the resources allocated to it. So whenever it is created, that is called the process creation, and when it is terminated, means the process either it has completed its entire execution on its own, or it can be terminated by the operating system or by the parent process itself. And termination involves clearing all the resources allocated to it. So when a process is running, it is taking some resources like memory or other input-output devices. Okay. So when it is terminated or it has completed its execution. So after that, once it has completed its execution, then it will clear all the resources. It will give it to back. So the next point is CPU scheduling. In a multi-programming system, multiple CPU needs to get the multiple process need to get the CPU. So the term itself says multi-programming means there will be multiple number of programs or multiple processes need to get the CPU. It is the job of the operating system to ensure smooth and efficient execution of multiple processes. So it is the job of the operating system to ensure smooth and efficient execution of the multiple processes. So whichever processes are there, it needs to have a smooth execution, efficient execution, and it is the job of the operating system to make sure that. Okay. Deadlock handling. Our next topic is deadlock handling. Make sure that the system does not reach the state where two or more processes cannot proceed due to a cycling dependency on each other. Deadlock, we will talk about it later. It is a very interesting topic. So for the meanwhile, just understand that it makes sure that the system does not reach a state where two or more processes cannot proceed. It gets stuck. Okay, and no process is willing to release its resources. Okay, so this is all about deadlock.